Water waves can be created and observed in a ripple tank. This is a common classroom experiment. In an exam, you won't be asked to describe how to do this experiment, but you may be asked to analyse a process like this one and its results. So let's go through the setup and the method to make sure we understand it. Here's an example of a ripple tank in use. A plank is periodically dipped into the water. This can be done either by having it bounce off these elastic bands, or you can set up a motor to move the support. As the plank is dipped in the water, it pushes the water down and displaces it. This creates water waves as the ripple from this displacement is transferred through the water. These waves can be hard to see, so often we won't be observing them directly. Instead, we have a light source, like a bulb or a projector, above the ripple tank. Since the tank has a glass bottom, this light creates the shadows of ripples underneath. Each shadow corresponds to the peak of a wave, where the light has had to pass through more water to get through the tank. So what can we learn from these shadows? Well, the distance between shadows on the screen gives the wavelength of the waves. Here's a diagram showing the ripple tank from above, with these lines representing shadows created by the peaks of the waves. Remember that the wavelength is a distance between two equivalent points on the wave, such as two peaks. So we can calculate the wavelength as the distance between two of these shadows. However, to get a more accurate result, we'll measure between multiple shadows. This helps to make our measurement more accurate. In this case, let's suppose we measured this distance and found it was 8 centimetres. Then we've covered 1, 2, 3, 4, 5 wavelengths in this space. We have 6 shadows, but remember we're measuring the spaces between the shadows rather than the shadows themselves. Using this information, we can calculate the size of one wavelength as 8 divided by 5, which is equal to 1.6 centimetres. So can we also calculate the frequency of these waves? The number of shadows that pass a certain point in a second is the frequency of the waves. Now let's look at our diagram again, but this time with the waves moving. Remember that frequency is the rate at which the waves are produced, or the number of wavelengths that pass a point in a second. We can measure this by counting the number of peaks, in this case shadows, that pass this point in a second. Again, we'll use a larger measurement to make our results more accurate. This time we'll watch the waves for 5 seconds after a shadow passes, and observe that 2 more shadows pass in this time. This corresponds to watching 2 wavelengths pass. So we can calculate our frequency as 2 divided by 5, which is 0.4 Hz. Now what can we then do with this wavelength and frequency? This information can be used to determine the speed at which the waves travel. The speed of a wave is the rate at which energy is transferred, or the speed at which the pattern moves. We can see this from our diagram as the speed at which the shadows are moving. To calculate this, we can use the equation speed equals wavelength times frequency. This is a very important equation for understanding waves. So for our example, we had a wavelength of 1.6 centimetres and a frequency of 0.4 Hz, meaning the speed is 1.6 times by 0.4, which is 0.64 centimetres per second. We could also measure the speed by timing how long it takes one of the shadows to travel a certain distance. Doing so helps us verify that this equation for the speed of a wave is correct.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!